All right, hello everyone. We're going to start a presentation right now on regular expressions. It's an intermediate level presentation, so some will be bored because it's too simple, others will be bored because it's too complex. I hope to capture a good happy medium. Some familiarity with regular expressions is assumed. All right. Okay, we still have some people coming in. I am going to commence because we are pressed on time. So I am going to briefly consider when to use a regular expression and briefly look at developer tooling and unit testing. Then provide a use case lookup table. Now what I mean by this is from a problem-solving perspective, when we look at documentation for regular expressions, it's got a whiz-bang style to it, and it lists the capabilities of the tool. I take a different approach and say, what do I want to do? And then, okay, here's where I will learn how to do it, or consider it further. I don't know where we're going with that. Okay. And then some theory and history as promised in the explanation. So this is great. A lot of stuff has quotes in it. I cite my sources at the end. So not all tasks can be done with regular expressions. Sometimes it's a good idea not to use a regular expression. This is not a man with a hammer in search of a nail. Consider regular expressions, consider some of the powerful techniques we're going to look at today. Also assume that it's not always the best idea. So, apologies to anyone who worked on PyRegX or Pythex. I did not have fantastic experiences with them. However, all three of these tools are good. If they're listed on here, they are one of my favorites. Regex 101 was particularly fantastic. It's got a great explanation engine. One can put a very complicated regular expression in there and get a detailed explanation of what it does, from character to character, from meta character, character class, and so on. In the end, I still found some discrepancies with what I got locally. This is what I was running. Continuum analytics, this is, I guess, probably the Anaconda build of Python. So, regarding unit testing of regular expressions. So here we have a regular expression to match a zip code. And we have a simple function which would return zip codes given an input. So, I've seen, just in the field, in practice, I've seen a lot of testing of regular expressions directly. And this makes sense, I think, when people think about how we tend to try and test things as atomically as possible. However, in this case, a regular expression at its most atomic is the expression as well as the interface with which we return our matches from it. And so I really do, I do recommend wrapping, whatever function will be wrapping the regular expression, make it small, ideally, not having much functionality, but do test the output of that function. It could be as simple as your test relies on finding metadata about the match, like its location. And your function is returning find all, is using find all. Find all will just return the matches as a list. So you wouldn't be able to access the span information. These are the kind of things that you would like to know. So by all means, make the function that wraps the regular expression small, but test that rather than testing the expression directly. I will just make mention to an alternative regular expression module, API compatible with the standard model. That's actually not completely true anymore. There are two different interface modes. No functionality here depends on it, but you should know it's out there. So, let's say you want to have a complicated regular expression. You want to make it easier to debug and maintain. You should use the verbose flag for this. I had a conversation as recently as my delicious lunch today, where someone did not know that they could add comments or make irregular expressions multiple lines. It's totally doable. So here we have the regular expression that looks at zip codes. Now we're passing the verbose flag, and I have a comment. I'm a fan of the zip +4. Whenever I fill out my address, I put in the zip +4. I like the zip +4. I enjoy the precision that it provides, or at least makes me feel that it provides. So I would notice that this regular expression is not going to match zip +4, but perhaps this is not a hard requirement to ship the software. So we have it to do. It's just a traditional comment. Doesn't do anything to affect compilation. We do this when we pass the verbose flag. So in terms of code documentation, it's clear how this is useful. It's also important to note, I am using the best practice of doing the raw string format. I encourage you to do the raw string format for all of your regular expressions, but if you're in this room, you're probably already aware of that. Lastly, the verbose flag will allow you to use to break up the expression over multiple lines or create indentation that will otherwise not affect the irregular expression. Clearly, this can make things much easier to look at sometimes. Let's say that you want to parse many lines at once which have the same structure. Use the multiline flag. So here we have, and I did try to make these useful. I didn't want them to be too toyish. So here we have a list of input lines. We've got friends, enemies, and we want to return the names of our friends. So we can actually do this simply with a regular expression. You'll see that I've highlighted and put in green the important parts. When we compile with the multiline flag, the start and end meta characters also they become the start and end of a given line. So in this case, we're matching by line. And just in case people are not familiar with groups, you can see that I've taken, I've put the dot and the plus sign where I would expect to capture the name into parenthesis, and this means that it's a specific group that I'm seeking. So I don't just need to return the entire expression match, which would obviously include the word friend. So I hear you want to differentiate between different types of input you capture. You can use named groups for this. So here we have some input. It is a simple key-value pair. It's an HTTP header. Let's pretend that this is some kind of raw input stream. Well, we don't need to pretend. This happens billions of times a day. So we can see here in our regular expression, which happens to be verbose, as many are, it's easier for us to read, that we have a series of groups. These are named groups, and they're nested inside of each other. So looking at this and looking at this together are useful. Now you can see that we can actually extract by name the keys and the values. Combine this with a multi-line expression. I wanted to try and isolate as much as possible. Combine it with multi-line expression, and it's trivial once we're doing this to parse a number of headers. But what's important and useful is that we can retrieve by name keys, we can retrieve by name values, and I mean that's just useful. One would invariably need to do that with or without a regular expression. So, hey, I hear you want to search for multiple matches, and you need to know each match's location. So find all, as we mentioned earlier, can't do that. You can get a match object back when you're searching for one thing, but if you want to search for multiple things and return multiple results, you use find all, you get a list. So you've lost all of the information except for the match returned. So we can actually use find iter for this. The documentation mentions, of course, that this is possible, but really doesn't push it. And I think that it's important to note. It's not simply for all of the good reasons for using an iterator regarding, I don't know, efficiency of memory use or what have you. So here we have a few headers. It's a superset of our last input. And we can capture the spans. So here again, I've highlighted in green what's important. So we create an iterator from the regular expression on the input. And then we can just simply, we get a match object back inside of the loop. And with that match object, we can do anything that we might do with finding an individual match via the search function, via the match function, the ones we've come to know and love. We need to welcome this into that family. So, you want to search for multiple matches, and you need to know each match's group. Well, once again, we have that metadata through the find iter method. So we can return this. So here we have the keys, we have the values, and we're actually, it's a bit of a side note, but I chose to display this using the group dict method, which, yeah, it's a convenient way to display this or putting on an array. This part is not as important, but what's important to know is that we can keep named group information, and to think some of us didn't even know of named groups a few moments ago. Now we're already learning how to take the named groups and return them when we have multiple matches. So really, I mean, the power, we're not just additive, we're multiplying the power that we have in front of us. This is great. It's like touchdown, right? So, here's a bit of a break from that Q&A format. Qualifiers are greedy by default. Now that sentence, out of context, doesn't mean anything. A qualifier is, for our purposes, something like a plus sign, an asterisk sign, what have you. So here, I have this input. It sounds sort of like I'm talking to myself. I was. So, I wanted to match my name. I wanted to match Mr. James Kropcho, Mr. James Kirk Kropcho, Mr. Kropcho. And so I wrote a rather a rather obvious regular expression to do this. I wanted to point out another subtle best practice here. So here I want specifically a period returned. That's not a meta character. It is common to escape that with a slash. That is totally legal. I find it a bit more intuitive. I find it less messy to try and avoid escaping characters with slashes. I actually instead just include them in a character class, which is what one calls between these square brackets. So either way is fine. I happen to prefer this way, and of course it does allow, it can get particularly messy as we add the number of characters that we would like to escape, which were formerly meta characters. So we match this. This appears as though it would do the thing that I wanted to do, but in fact it matches as highlighted. The qualifier is greedy in the sense that it it tries to gobble up as much as it can. We actually, and this is tough for us because, you know, it's performing correctly. It's matching as we asked it to. It's got the stuff in the middle. Matches too much. You know, I'm just going to say it. I'm sorry, you match too much. So facing ambiguity, your pattern behaves as expected, but it chooses a match too long. I've got an answer for that. You can read it right now. We use the non-greedy qualifiers. So we use the other qualifiers, the ones that we've used, the ones that are in all of the, you Google or use DuckDuckGo for Python regular expression tutorial. We learn of these. So we add a question mark to them. And when we add a question mark, they're non-greedy. And they will match as desired. They match as I would like them to match. And so here we can highlight, we have a green highlight again, an underlined green highlight, where we're matching any character, 0 or more, so, you know, to accommodate for Mr. Kropcho. And we have the non-greedy qualifier, the question mark next to it. So, you want to match a pattern depending on what's before or after it. This is useful, often. This is done all the time, although it's normally done outside of a regular expression. which sometimes is a good idea, sometimes not. So we use a positive or negative look ahead or look behind assertion. I considered putting this inside of a regular expression. I thought it was too clever. You've been spared. So here's a great example. So John is apparently very lucky. He just has mathematical constants for phone numbers. And we only want his mobile number. Well, this is rather difficult to do because all of these are identical from the perspective of a regular expression. So in this case, we can actually tell the regular expression, I only want the numbers that come after the naming of the number being mobile. And we will just return that number. So it's a way to look at it's a way to match not by the actual structure of the pattern we're seeking, but to match by the structure of the information immediately before or after. Clearly quite useful. Now for something completely different. Finite automata. This is a DFA, a deterministic finite automaton for matching the word mommy. So we can go through, and this is how the word mommy would be matched. I'm going somewhere with this, trust me. So we can just imagine looking for, we found an M, we got another M, didn't quite want that. Oh, we found an O. Now we're in O territory. That's great. If we get an F, we're back to the beginning. A transition is not specified, return to initial state. So this is a finite state machine, an automaton, a finite automaton that will match text. This relates to the origin of the term regular expression. So this is two logical steps. So a regular language is one class of formal languages. It's by definition, it can be recognized by a finite automaton, like the one we just looked at. And a finite automaton has an equivalent regular expression. This is a mathematical proof. So, A to B to C, this is how the term regular expression came into existence. Now, it is important to note that it's no longer quite the case because modern regular expression engines have extended features. So, incredibly useful, very interesting, and a great start to exploring 90% of the way there, really, towards exploring regular expression engines. So for further reading, this is, I prefer less to more. I'm just going to recommend, a few things. Python documentation, fantastic. It's obviously the majority of what this is based on. And Sipser's computation book, I'm a big fan of it. It's great. It covers a lot of material rather quickly and well. And one of the things it covers is automata and then builds from there. These are works cited. This is the license that the talk is given under. And oh geez, who put that in there? I don't know. I must ask someone to edit this and they put that in. Oh well. So this is a question and answer period, which means that the formal part of the talk is over and I have a few minutes to accept questions if anyone has them. Thank you. Bravo. I see one. This fellow.
You mentioned the regex module having expanded support for Unicode. Could you expand a little bit on that?
He asked about me mentioning the regex module expanding support for Unicode. I did not mention that, but I can, yes. So the regular expression module in Python 3 that ships is Unicode compatible. If you want to match whitespace, for example, it will match Unicode whitespace. That is independent of the regex module, which I assume can do that and more. Do we have any other quick questions? Or just, I don't know, regular questions? Do we have any questions? All right, well, I'm going to call it. Anyone who wants to can talk to me afterwards about anything at all that you would like to talk to me about. All right, well, take care and have a nice rest of the conference, everybody.